This is Earthfiles, the award-winning news site with the latest updates in science, environment, and real X-Files. Podcasting in-depth reports beyond the 6 o'clock news by Emmy Award-winning journalist Linda Moulton Howe.
The United Nations Intergovernmental Panel on Climate Change, known as the IPCC, has been working on another report since its last one in 2001. This is supposed to be a consensus from scientists and computer labs around the world about where global climate change is headed. This report says it is, quote, very likely, unquote, that increasing carbon dioxide is caused by human activity. The report also acknowledges that there has been an increase in stronger storms in various parts of the world, and specifically, storms in North and South America are linked to global warming. How high does the IPCC now think the average global temperature will rise over the next 90 years? The official February 2nd, 2007 public report says that by the year 2100, Earth could warm up in a range of scenarios from 1.8 degrees to 6.4 degrees Celsius. That is 3.2 to 11.52 degrees Fahrenheit. That upper 11.52 degrees is even higher than the previous 2001 projection of about 10 degrees Fahrenheit. It means, in the worst case, each coming decade could warm at least 1 degree Fahrenheit. For comparison, it took the previous 100 years for the Earth to warm up 1 degree Fahrenheit. And how high will sea levels rise? For reasons that are not clear, the rapidly increasing ice melts of Antarctica and Greenland were left out of the initial draft of the IPCC's 2007 report, allegedly because computer models don't have current data to accurately assess the impact. The February 2nd, 2007 final IPCC report projects only a 28 to 43 centimeters or 11 to 17 inches rise in sea level by the year 2100. But scientists who have been studying glacier ice melt their entire careers are alarmed at recent increases in the rate of Greenland and Antarctic ice melt. This week, I talk with Lonnie Thompson, Ph.D., Distinguished Professor of Geology at the School of Earth Sciences, and a research scientist in the Byrd Polar Research Center at Ohio State University in Columbus. He thinks the worst case for sea level rise could be 5 times higher than the IPCC's most conservative estimate.
When you look at those numbers that the IPCC 2007 document give for increase in sea level, it's like 5 inches to something like 23 inches. And I think this is way understating what we know. So I have problems with that. I know a number of scientists around the world have complained about this being inadequate number based on what we know. And you cannot ignore Greenland and Antarctica, where we have most of the water stored in ice on land.
So does that mean that the UN has come under some political pressure to basically falsify data in what should be a scientific report?
Well, that's an interesting question. Unfortunately, IPCC is a science document, but also a political document. It has to be signed off on by 154 countries, including the United States and oil-producing countries, and so it tends to be conservative from that perspective. But I think on top of this is that there is a lot of uncertainty about our knowledge of how these big ice sheets are actually going to respond to increased warming. But what we do know is over the periods where we have observations, and we have now satellite observations of these ice sheets, that changes due to the current climate are dramatic. There are quite likely to be some surprises as we go forward in an unfamiliar climatology.
What do you think is a fair estimate about what the sea level rise will be by 2100?
The thing that I have been surprised with, having spent my life the last 30 years on some 51 different expeditions around the world, is just how fast ice can respond to climate change. And so I think we have really underestimated the rates at which ice can disappear on land. And when it disappears, of course, that's just water, frozen water that makes its way through the rivers and into the oceans of the world and leads to global sea level rise.
So if you were making an educated guess, what do you think a fair estimate of sea level rise will be in the next 90-some years?
I find it more reasonable to look at numbers like in the order of 30 to 40 inches of sea level rise. But we have to be prepared for more extreme changes because of the uncertainty and the surprises that we've seen in the last 5 years in how fast ice can actually disintegrate.
What do you personally think is the worst case for this century in terms of sea level rise?
Well, I think the worst case is up on the order of 55 inches. It's certainly a possibility.
Mm-hmm. And if it made it to 55 inches, how much of Florida would be gone?
Well, we would be looking at over a third of Florida disappearing.
And a third of Florida, and how much of the Gulf Coast?
This is exactly what we're working on, but it would be significant. All that infrastructure that has been built, I mean, places like New York City, potential cost impacts of those types of sea level rise are tremendous.
And it would mean that New Orleans was not at all a place that would survive.
Exactly. This is why these projections are so important, because we're right now investing a lot of resources in rebuilding in New Orleans. The question is whether that's money well spent.
What year do you think, if we're heading for a 55-inch sea rise worst case, when would New Orleans, Florida, and the Gulf Coast know that it was no longer possible to have real estate along the current coast?
Well, I think they're already realizing in the really low areas like in the Everglades where you're right at sea level, the salt incursions that are coming. If you get an inch rise in sea level, you will displace the vegetation and animals a mile inland in those areas because you're right at sea level.
For every inch of sea level rise, you're going to have a mile of incursion of ocean water inland.
Yes. That affects the type of vegetation. When you look at those ecosystems, you go all the way from the salt-adapted type vegetations along the coast to the freshwater vegetations as you go further into the Everglades. Those boundaries will shift as sea level rises.
When you say it might, at worst case, be 55 inches by the end of this century, those 55 inches would then translate into 55 miles inland.
That's pretty much correct, yes. The actual how far inland it goes depends on the topography, the elevation that you're looking at, but the change can be tremendous.
And that's why a third of Florida's coastline could be gone.
Exactly.
Today, in 2007, the measured amount of carbon dioxide in the Earth's atmosphere is 381 parts per million volume. The last time it was at this level was between 1 million to 20 million years ago. Long before that, nearly 300 million years ago in the late Paleozoic, CO2 levels rose to 1,000 parts per million and higher. That's when ice melted all over the planet. Then the CO2 levels went back down. Earth's CO2 levels have been like a yo-yo, going up and down for millennia, and no one knows why exactly. Maybe volcanic eruptions. Scientists have learned that when CO2 levels fall, the Earth cools down and there have been many ice ages. Then when CO2 levels rise, the Earth warms up, the ice melts, and sea levels rise. One scientist who recently studied geological evidence from the late Paleozoic era reports that as CO2 levels increased toward 1,000 parts per million and higher, the climate was highly erratic and very stormy. She is Isabel Montanez, Ph.D., professor of geology at the University of California, Davis. She and other researchers are concerned that since computer models indicate CO2 levels are now expected to double to around 800 parts per million over the next 90 years, will the whole planet be challenged by increasingly erratic weather? If so, how many coastline populations will have to move? And how much Earth life will be forced into extinction?
There are those who say if we burn through our fossil fuels more aggressively than or basically at the same rate of what we're doing now, then we're going to look at 1,000 parts per million or more. But this is all happening at a much faster time period than in the past. I mean, this is happening in decades, if not a century, century and a half. So the parallel to the future then is that if we see such unstable climate in the past, whenever CO2 goes up dramatically, should we expect that climate and life on Earth is going to respond just as erratically when this CO2 continues to go up, but at a much faster rate? And that's what the big uncertainty is, because we really don't know how to predict that. We don't know how to model and predict future change when it can be erratic.
What caused the CO2 to rise in that 40 million years that you studied?
Right. Well, it's a sort of $1 million question. The best guess, we have actually still to investigate this far further, but there was naturally an increased amount of volcanic activity, quite a bit of it, in part because the continents were all colliding into one another. And so there was certainly a source for CO2 to go up. And that's probably a pretty good connection we see there. What's not clear is how it yo-yoed. Why does it come back down and then go back up and yo-yo? And it probably has a lot to do with, at the time we had a lot of tropical rainforests in the equatorial regions, really much larger than today's rainforests. And they probably did a good job of sweeping out a lot of this CO2 in the atmosphere, but clearly couldn't keep up with it. So that may be the reason why things were sort of yo-yoing until eventually CO2 took over and just got high and stayed high.
Now, if CO2 yo-yoed then, what was the worst case of erratic weather behavior?
Well, the first thing I would say from this study that might be a direct parallel is that it seems like that window of 1,000 parts per million is a window, what we might call a threshold, where ice may be stable below that level, but it seems, at least in our records, when we hit 1,000 parts per million, whether we're going up in CO2 or down, that seems to be the stability point for the ice sheets to come back or to melt. We have a lot of uncertainty on those values, there's no doubt, but it's not the first time that a study has come out and suggested that magic window of about 1,000, 1,200 parts per million. The other time period is when we actually developed our ice here on Earth in the last 34 million years, when we got Antarctica and then the northern hemisphere ice. So if that 1,000 parts per million window is real, then it's pretty scary, because that's, like you said, we're sort of approaching that. Big change in CO2 can be associated with very unstable climate, meaning in terms of absolute numbers, we see temperature changes in the tropical oceans on the order of 4 to 7 degrees Celsius. In the past, on the shorter time scale, they too have seen changes of about 3 to 4 to 5 and maybe even a little higher degrees in the tropical oceans as well. And then that leads to a whole domino effect, when you start to change the ocean temperatures so much.
Lots of extinctions.
Yeah, ultimately it can, and no doubt about that, and we see it in our records with the plants. But if you change the temperatures of the oceans, you change its circulation. When you change its circulation, you also change the way it interacts with the atmosphere. And ultimately that then changes climate and weather. So things like much more extensive storminess, much more even increased temperatures in the air because the oceans are releasing their heat, and even more sources of greenhouse gas. So it can be an accelerated warming even. When the circulation of the ocean changes, so do the climates, especially in areas like Northern Europe and Great Britain, Canada. They can really get cool quickly and kind of oscillate back to very cold and then very warm again. And sure, anything that lives in these regions that can't migrate at the rate to keep pace with this climate change, they have one other choice, extinction.
What is the worst case that comes out of your research in terms of how bad the wind could become, hurricanes could become, water in terms of torrential rains? How bad could it become just in this next 90 years?
One of the things that we see is that when we get into these periods of 1,000 parts per million of CO2, the monsoonal type climate intensifies dramatically. And that's because at this time there was a huge monsoonal system, very much like those in Southeast Asia now, but much bigger scale. But what it really that means is storminess. And no doubt when we hit that threshold where we start to lose some of the ice caps, it changes atmospheric circulation enough. It makes the exposed continents now much more capable of warming the atmosphere, and you get increased storminess. No question about that. The 382 parts per million that we have now already is higher than we have seen probably in the last 20 million years, for certain in the last 600,000 years. So already we are outside of the norm of basically stability for this planet. And with that increase beyond the norm, we've seen already a little warming, a half a degree Celsius. But we also know that those levels are going up. And there's nothing we can do to stop them, I think, at this point, from going to at least 500. If we don't do major changes to the way we use energy and operate, we'll probably go to these doubling, the 800, 900, maybe 1,000 or more. And we fully expect that with that increase in CO2, there's a parallel increase in warming, so much more than the half a degree we've already seen. And with this warming, then, there's the ice issue, the instability of the ice.
And if you were, based on everything that you know so far, going to make an educated visual picture for the current population about what the planet will be looking like in another 90 years, what would you think?
Yeah, I mean, I think about that a lot, actually. I have 2 kids, but also, I just, academically, but also as a human. I think that going to a seasonally ice-free Arctic is very reasonable. I mean, I think that's going to happen. I don't think we're going to escape that. Inevitably, that will impact ocean circulation. And that means that much of northern Europe and Great Britain is not going to live the way they are living now. They won't be able to. They will have very erratic, very stormy weather. That population will need to survive somewhere else, likely migration to more southern locales. And areas like the equatorial regions, the tropics, subtropics of places, developing countries like Africa, they will probably see much more drought. So they, too, will need to find alternative locations to grow their products and to live, as well as like the Middle East. And I think we'll see places like India and Bangladesh, low-lying areas that will be seeing increased storminess, that will also need to deal with the increased flooding and disasters of these mega monsoons. So the bottom line to me is, where are we going to put as many people as we have already, plus the increase, in that much less inhabitable land on Earth? And then there's issues like disease. A lot of these migrating species that we've talked about going extinct, those who do migrate are usually insects, because they can. Mm-hmm. And that means disease-bearing insects like the malaria. I think it could potentially be economically devastating.
What do you think is going to happen to the United States and Canadian climate?
The United States is they're strongly impacted in that the mid-latitude northern hemispheres are going to see major changes, but it changes by region. So, for instance, for us here in California, we worry very much about water resources, as does the whole Southwest, because we, here in California in particular, we're so dependent on snowpack and that seasonal rain, and because we move water around so much, so we impact a lot of people. We'll see more drought, probably, as will much of the Southwest. I think for the mid-continent, where we grow, the breadbasket, they too worry, because they are predicted to have much lower soil moisture, more drought, certainly earlier growing seasons and later frosts. The East Coast might actually become much more wet and much stormier, but warmer, it's milder winters, which isn't always a good thing. And then clearly for the Gulf of Mexico region and southern Atlantic part of the U.S., that's an issue because of hurricanes. Hurricane season will be far longer-lived and probably much more intense. When we do have hurricanes, the idea that they could be Class 5 with these 200-mile-per-hour winds, that's very feasible, and they could be much more frequent.
More Katrinas.
Oh, more Katrinas. Certainly the modeling predicts that there should be more Katrinas.
What is the worst case for the next 9 decades?
Definitely sea surface temperatures in the tropics can change. And that's important in that we didn't think that was the case. We thought the tropics were pretty buffered, that was the part of the Earth that was stable. And it's not so stable. It can get warmer by more than we thought. That's not good, because when that happens, a whole lot of other things happen in response. And hurricanes happen more often, things like that. Circulation of the ocean changes. The other thing is that we looked at the vegetation in the tropics, and there were remarkably large migrations of rainforest-type plants, the ones that would normally live in our tropical regions today. They like it wet and they like it warm. They migrated, in this case, very far distances. We don't know how much, but minimally tens and if not hundreds of kilometers. And in their place, when global warming came on and when the ice started to disappear and CO2 went up, in their place came the opportunists, the dry land plants, the ones then that were conifers and ancient pines, but today are things like shrubland and weeds. These guys are opportunists. They can live in very severe climates, but we don't live off of them, and they don't do the beneficial things that the rainforests do. Very few people really appreciate how much it does, that it is the sink for a lot of atmospheric CO2. It takes out quite a lot of CO2 out of the atmosphere. And if you don't have that photosynthesis going on, that's that much more you keep in the atmosphere.
And if I have understood correctly, in 90 years from now, if the CO2 continues to rise, the gigantic equatorial tropical rainforests might even be dead?
Very possible. First thing I usually mention when I think about what will my kids be thinking when they're grandparents, and one of the things I actually sort of comment on is I don't know that they will have rainforests. I think the tropics will look very different, in part to accommodate all these people that are going to have to move to different areas, but also just because I don't think the rainforests will survive this change.
Thanks for listening to this Earthfiles podcast, from the edges of science, environment, and real X-Files. Go to www.earthfiles.com to see more than 1,000 Earthfiles reports with photographs, drawings, and documents. And visit Earthfiles every day, every week, for new reports and new podcasts. That's www.earthfiles.com.